Hello everyone, welcoming you to Shaurav's classes. And today we are looking at the University of Hyderabad Economics entrance exam paper and question number 1. So if the inverse supply and the inverse demand functions of commodity X are given by PS equals to 8 plus 4x and PD equals to 20 minus 5x respectively, and if the price P and quantity X are determined at the equality of total demand and total supply, then the total surplus is approximately equals to the four options. So first of all, what we need to do is to obtain the equilibrium price and quantity. So we can straight away equate the inverse demand and supply curves. So at equilibrium, demand equals to supply. So in this case, the demand price will be equals to the supply price. So the supply price is equals to 8 plus 4x is equals to 20 minus 5x. So 9x equals to 20 minus 8. So 9x is equals to 12. So x equals to 12 by 9, which is equals to 4 by 3. So putting it anywhere, let's say in the supply equation, so it is 8 plus 4 into x, so it is 4 by 3, so it is 8 plus 16 by 3, so that is 24 plus 16 by 3, so that is 40 by 3. Okay, so if you just have a brief plot over here, what we can easily see is that if the demand curve is a standard demand curve, the supply curve will be a standard supply curve. So this is your demand, this is your supply, this is your price, this is your quantity. So the equilibrium quantity, the equilibrium over here comes out to be 4 by 3, right? And what's the measure of the total surplus? It's basically this area, right? So this is basically consumer surplus plus producer surplus. So basically what it is the area between the demand and the supply curve in the range 0 to 4 by 3. Therefore, what will be the total surplus? It will be basically integration from 0 to 4 by 3, the supply curve minus the demand curve. So if you just substitute the equations, the supply curve is 8 plus 4x minus 20 minus 5x dx. So this is what we need to evaluate. So this is the integration from 0 to 4 by 3, 8 plus 4x minus 20 plus 5x dx. So this is basically integration from 0 to 4 by 3. So this is 9x minus 12 dx. So this will be 9 times x square by 2 minus 12x, and this thing, entire thing, evaluated over the range of 0 to 4 by 3. So 0 need not be evaluated, so that is 9 by 2, 4 by 3 whole square minus 12 into 4 upon 3. So that is 9 by 2 into 16 by 9 minus this will go also minus 16. So this 9 and 9 will get cancelled, and this will go 8 times. So that is 8 minus 16, and we come up to minus 8. Um, there's been just one small mistake from my side. I'd just like to correct it. So you can see that the demand curve is above the supply curve. So the integration would have been correct truthfully. Like this expression will slightly change. So this is basically 0 to 4 by 3 demand minus supply. We just did the reverse. So nothing much will happen. If we just put a minus over here, the answer instead of minus 8 will become plus 8. So the total surplus will become 8 units. And if you have a look at the options over here, so that is basically option number B in your answers. Okay, we now move on to the second question of the 2021 University of Hyderabad paper, which says that if we have a Leontief production function y equals to minimum of ax1 comma bx2 with two inputs x1 and x2, the associated total cost function will be Leontief form, Cobb-Douglas form, linear form, or um, non-linear form. So let us first write down the production function over here. So the production function is basically y equals to minimum of ax1 comma bx2. So what happens at optimal? Ax1 equals to bx2 is equals to y, which implies the optimal amount of x1 that will be used equals to y by a, and the optimal amount of x2 that will be used equals to y by b. And what is the cost expression? Is basically the payment made to factor x1 into payment made to factor x2 into the units of factor x2 purchase. So in place of, so the cost function will replace by the cost minimizing value of these things. So this will be y by a plus w2 times y by b. So you can understand we get an expression like w1 by a plus w2 by b times y, which is basically linear in y, right? And therefore the cost function is linear in form, and this is basically given by option C of the set. Thank you. So now let's move on to the next question, which is question number 3 of the M Economics 2021 paper, University of Hyderabad. So in a simple Keynesian model of closed economy, the marginal propensity to consume MPC is equals to 0.8. If the income tax at the rate of 25% is introduced, then the simple Keynesian expenditure multiplier changes by which of the following proportions? Okay, so now let me just write down the setup of the simple Keynesian model in case we have forgotten. So simple Keynesian model, which in short we write down as the SKM. So what are the basic structures driving it? So the consumption function is given by C bar plus C prime Y, right? Where C prime is the marginal propensity to consume, which lies between 0 and 1, and C bar is the autonomous component of consumption, which is greater than 0. Investment is autonomous, I equals to I bar, and the government expenditure is also autonomous, decided by the government, right? And at equilibrium, so since it's a demand determined economy, so what do we have at equilibrium? Y equals to C plus I plus G, right? So if you just expand it out, so C can be replaced by the consumption function, investment is anyway autonomous, and this is G bar, right? So if you take the 1 minus C prime on the left side, and you have basically left with C bar plus I bar plus G bar, correct? So now in order to understand how the expenditure multiplier can be computed, expenditure multiplier is basically the change in the GDP due to change in government expenditure. So expenditure multiplier basically implies that DG is positive. So if we differentiate both sides of this expression, so 1 minus C prime times dy equals to C bar and I bar don't change, so it's DG. So that is dy by dg is equals to 1 by 1 minus C prime. And look over here, the MPC has been given to be 0.8 over here. So if I just substitute it, so it is 1 by 0.2 over here. So that is 2 by 10. So that is 10 by 2, which is equals to 5. Correct? So this is the government expenditure or multiplier in the absence of tax. Now comes part B, which is if the income tax at the rate of 25% of the income is introduced. So we have a proportional tax in the sense that small t, proportional tax at the rate of 25% is introduced. Correct? So the small t that we take is basically 0.25. So what is my modified consumption function? It is c bar plus c prime into y minus capital T, the total taxes. And so which will become c bar plus c prime into y minus small t times y. A part of the income is taxed out. So now at equilibrium, what are we having? Y equals to, again the similar expressions will be evaluated. So C is equals to C bar plus C prime into Y minus T times Y plus I bar plus G bar, right? So if you this 1 minus C prime into 1 minus T times Y is equals to C bar plus I bar plus G bar. So now again we'll consider the expenditure multiplier. So for the expenditure multiplier, we will have dg greater than 0. So 1 minus c prime into 1 minus t times dy is equals to dg. So what's the dy by dg post tax is equals to 1 by 1 minus c prime into 1 minus t. So that is basically C prime is 0.8 and this is 0.25. So we just need to have this calculation done. So that is 0.85 into 0. So this makes it 1 minus 1 by 0.6, which is 1 by 0.4. And that basically gives us an expenditure multiplier of 2.5. Earlier it was 5 and now it is 2.5. So it has basically reduced to half. So the change in the government expenditure multiplier is minus 50. It has reduced to half. Earlier it was 5, now it is 2.5. So the change is minus 2.5 and that's why it is coming out to be negative. And this is your answer, option D, for question number 3. Thank you.